given f of x is equal to the square root of x and g of x is equal to the square root of 5 minus x, we need to find f plus g of 2, and we need to find f over g. So f of g plus 2, remember, we can write it as f of 2 plus g of 2. So let's see. F of 2 would be the square root of 2. G of 2 would be the square root of 5 minus 2. So our answer would be the square root of 2 plus the square root of 3, which does not simplify to the square root of 5. You cannot combine those anymore. For f over g, we're not given an x value, so it's just basic writing it as the square root of x over the square root of 5 minus x. So this one's interesting because we have to make sure our radicals cannot be negative. So we have to say, when is the square root of x greater than or equal to 0? When is the square root of 5 minus x greater than or equal to 0? Square both sides, and you're going to get x must be greater than or equal to 0 here. Square both sides here, you get 5 take away x is greater than or equal to 0. And my big head is in the way, so let's move this camera. So now we are going to subtract 5. Of course, my pen went away. On both sides. So now you get negative x is greater than or equal to negative 5, which means when we flip the sign, we get x is less than or equal to 5. So we have two parts of our domain here. Our domain's got to be greater than or equal to 0, and also has to be less than or equal to 5. And remember that underneath the denominator cannot be equal to 0. So when does 5 minus x equal 0? Subtract your 5. Negative x equals negative 5. So x cannot also equal 5. So our domain's got to be greater than or equal to 0, but at the same time less than or equal to 5, but it can't equal 5. So our domain for this problem is going to be written as in blue as 0 is less than or equal to x, which is now less than 5. Why just less than 5? Because down here we said it cannot equal 5.